Hi. Today we'll talk about online ads and when to show an ad in a content-focused user experience. So online ads is a big industry. Global ad industry hits $1 trillion in revenue, and usually there are many experiences where users come and there is a series of content that they consume. Think of YouTube, Spotify, Twitter, etc. And and the choice that ad mm, supported platforms have to make is A, which ad to show, and B, when to show. Today we'll focus on when to show, specifically between the content. If you're thinking of ad slots, which ad slot to show, and even that is a general problem, but we'll take a sliver of it. It's actually a very impactful sliver. Is whether to show the ad in the first slot, so even before you have shown the content. Okay, so industry is huge. One big problem there is when to show the ad, and we'll focus on it on a sliver of it, which is whether to show the ad in the first slot. This we can think of it as two actions: whether to show the ad or not to show the ad. And the first approach we'll talk about is a blending approach, where we'll say that, hey, there's the ad and there's the content. We'll try to get a value for both of them, bring it to the same scale, and see whether the value of showing the ad is more. Then we'll see why this is not the right framing, why this will not produce what are intuitive results. Then we'll go to a better framing of it, which is around engagement loss. And then we will use reinforcement learning approaches for this. Okay. So yeah, often when you're building a feed of content, it's natural to say that let's look at different types of content, different options of content, and for each of them, try to estimate the value that the ecosystem will get. Now, in case of an ad, the value is to maybe the creator, maybe the ad producer, and hence the business which is supporting the platform. Since it's an ad, we are assuming this is an ad-supported platform. And on the content side, the value is probably to the user, and this is probably why the user has come here in the first place. So this should drive engagement or time spent, which in turn should develop the habit of retention, should develop long-term revenue. So let's say we have a separately estimated transfer function, that how much does an additional engagement for this user specifically, and we can personalize it, but how much does this additional engagement translate to expected revenue? In this way, you can compare both of these in the same scale. That we had an option of showing an ad or the content, and we brought them to the same scale, and we showed whichever one was high. Right? So there's a plausible approach. In fact, blending, feed blending, is very common between different sorts of content. For instance, if you are making a feed on, let's say, Twitter, for instance, and some items are videos, some are posts, some are text heavy, some are images, etc. Often the modalities people engage with, even the metrics you have, like watch time of videos versus maybe clicking and sharing, etc., of commenting, etc., of posts, they're quite different. So you have to bring things to the same scale when you're blending. So blending in for feed construction is a very tried and true approach, and tried and tested approach, and it makes it would appeal to common sense, except this might not work in the case of ads. Why? So see, we are we're deciding whether to show the ad before the content. Now, it is totally possible for your power users that this is not a trade-off in this sense, that often after the ad, they might end up consuming the content anyways, because they're here for the content, they have a habit of coming, they don't want to leave without consuming what they wanted to. So really what you're looking for is not so much the comparison between these two, but what is the loss in engagement on showing the ad. But before I go there, I wanted to also talk about modularity of ad decision making or ad placement. One aspect of this is expectation of revenue. We are not touching upon that. We are assuming there is a separate, quite complex perhaps, ad revenue estimator model, which looks at the user and the ad that you're going to show and computes the revenue. At multiple times, you'll see we will use this estimator model. We will not try to build this. Today, we are only focusing on whether to show an ad in the first place. So, okay. So we looked at blending, and we saw that blending doesn't quite capture the decision because, for instance, for power users, if the cost of showing the ad in terms of engagement drop is very little, you would want to show the ad. However, for power users, blending will say that actually you should not show the ad. Why? because they are the users who really will engage with your content. Hence, this part of it will be very high for them. Could be very high for them, depending on how you frame it. So what you're really looking for is, if you show the ad, what is the expected engagement loss? Okay, so now this is our first baseline. This is a data analysis heavy, where from data analysis you can find the transfer function between engagement and revenue loss. Based on your ad estimator model, you can come up with the expected revenue for the ad for this user. And now what's remaining is the expected engagement loss. The expected engagement loss here can be, as predict that, we can take uh, training rows where in some rows you showed the ad versus in some rows you did not. And given the user features like the past engagement of the user, even maybe you have some signals from your content recommender system about what is the likely engagement of the user with this item. Using all the features you want, you can try to predict what is the net engagement of the user, time spent of the user, etc., of the session when you showed an ad, and what was it when how try to predict it when you did not show an ad, and then the difference of it is the expected engagement loss. Now we'll come to sort of the meat of our talk. How can we use reinforcement learning to achieve optimal ad placement? So in the past, we looked at that it's a good decision framework where you have the expected revenue and you can estimate the expected engagement loss. We're sort of continuing along the same path, but we are directly looking at the net impact of the decision. So here we are defining a net session reward. So again, the framework here is that you have collected a lot of data where in some rows you have shown the ad in the first position and some you have not. And for each row, each training example, each session that you have data for, let's calculate a net reward, which is the revenue plus some conversion applied to the engagement. And one suggestion I make, just for your system to be not black box but to be steerable, is to have a sort of a dial, a multiplier, if you will, so that you can train your model to either give more or less priority to engagement as per the requirements of your business. Right? This is just a small reward shaping sort of suggestion. Okay, now you have your data, which is you have either the action was taken or not taken, and what is the reward of that session. Now, one approach is what is called a multi-ounce bandit, and a personalized version of it, which is called contextual bandits, where you train two separate models: reward model on taking the action or showing the ad, and a reward model of not taking the action or not showing the ad. These are trained separately. Think of these as regression models, which the input features are all the user features that includes previously how much this user has interacted with your platform, maybe what is the length of the usual session, maybe the expected revenue from the model, from your ad estimator model, all sorts of features, right? And there'll probably be a lot of ROI of feature engineering here. But now with the features, you have two models which try to estimate the net reward of showing the ad versus not showing the ad in the first position. And now when you're acting for the decision-making framework, you will show the ad if the predicted net reward is higher than not showing the ad. But here there are two actions here: show the ad or not show the ad. And context, when you use context like user features to inform your decision of the probability of taking those actions, that's the reason for calling it contextual bandits in reinforcement learning literature. But is this the only way? No, there is what I believe is an improvement. This is called policy gradient is the general area. In particular, we'll talk about the reinforce approach. But here we are estimating the reward, and then we are taking action deterministically based on the expected rewards of these two actions. The problem is that you're actually having to solve a very difficult problem. You're actually having to solve two very difficult problems. What is the expected reward when you are showing the ad or not showing the ad, or like in more general setting, the expected reward of taking the action or not? But what you really care about is when you should take the action, right? You don't really care about having a very good estimate of the reward if you take the action. That was kind of a intermediate step, if you will, right? So policy gradients say the policy is a term used to for the decision making framework, and policy gradients say that how can we just directly learn to optimize the decision making framework, the policy, using observation. And there's a great tutorial of this, of using deep reinforcement learning for a binary decision, from Andrej Karpathy's talk on Pong, I think about 7 years ago. And we're talking very much the same solution here. And you'll see that in our GitHub repository, this one, where there are two directories, the contextual bandit and reinforced policy. And if you go into the reinforced policy, the policy model, this is forward is where it chooses the action. It comes up with the probability of taking the action. So forward is what you need when you're using the policy to decide whether to show the ad or not. And train forward is the function where you are improving the policy. Let's look at the train forward today. So it for all your training data, it estimates the probability of taking the action. So again, remember, forward takes one row of your training data and comes up with the estimate of whether you would have taken the action, that is, shown the ad or not. And in your case, you also have a notion of a reward. Okay. Now, you're also told in that training example whether you took the action or not. Right. So this part says, let's compute the log probability of the chosen action. So imagine in this training row you had taken the action, then this part will be active. And if you're not taking the action, then this would have been active. Regardless, in both of these, whichever is active, you're taking the log probability of the action. And this probability is what your model comes up with. And then you aggregate this over all the data points. This is the reinforced approach of train policy gradients. And a good book on this is Sutton and Bartow's book on reinforcement learning, specifically the chapter 13. I encourage you to read it. It talks about policy gradients and special cases where the policy comes from softmax, which is something that we use in our code, and then policy gradient theorem, and this is the part reinforce that we use here. Okay, so coming back, we optimize using contextual bandits, but then we directly optimize the policy, which is much more efficient because you're not having to predict these hard intermediary steps, and you're directly optimizing the last decision. Again, the tutorial by Andrej Karpathy is very awesome. We talk about some pros and cons of using reinforce. And lastly, this section talks about, we have a pretty awesome ad revenue estimator model. Let's assume that, because that's a separate problem, and one that is that you'll have a lot more data for than the specific one we are talking about here. Here we're talking about when to show an ad, but separately you can have a very good model of what is the expected revenue of showing an ad. But we are not. It feels like we are not using it optimally. We are using it as a feature, but we have not really used it in the reward, in the label. So in this section, we talk about how to separate the session reward. Remember, we talked about the net session reward. One part of it was session revenue, but in the specific case where you are showing the ad, you can have the immediate reward is actually very nicely estimated using your ad revenue estimator model. So what you can do is, when you're predicting the net session reward, you can say, hey, one part of it is easy, it's kind of already done, which is the revenue of this ad. I'm just going to focus on the rest, so the delayed reward, if you will, and try to, if you're doing estimation, if you're using the contextual bandits approach, for instance, you can focus on predicting that and using your ad revenue estimator for the first part. So I'm going to a little bit of a specific, implementation detail in section 3. I believe this will be valuable if this is the sort of state you find yourself in, where you have a really high quality ad revenue estimator, and now you're working on the specific problem of when to show an ad. But if you're not, if you are kind of starting from scratch, then frankly the approaches, approach 2A as contextual policy gradient and approach 2B reinforce. 2A being contextual bandits and 2B being reinforced based policy gradient might be a great start. I would, one of the benefits is that you don't necessarily have to rely on the separate ad revenue estimator. It just looks at the session revenue, which you will have data for. So that's what we wanted to cover. In summary, we show how to use reinforcement learning to learn when to show an ad. the framework extends to other positions, not just the first position. The reinforcement learning policy also encapsulates exploration, because see, when we are doing it through the through reinforce a policy gradient, we actually come up with the probability of taking the action. Now you can sample the action with that probability. So let's say the probability came out to be 90%. You don't have to, you don't have to like take the action. You can say with 90% probability I'm taking the action. I'm going to take the action, and that exploration can provide you the data for continuously improving. You know, um, and lastly, we show in the last section we show how to develop this policy of when to show an ad using your ad revenue estimator model. So hence our structure is modular. It is continuously learning. It is using state-of-the-art approaches like policy gradient reinforcement learning. Right. Hope this helped as an educational post. Again, this is doesn't relate to any other companies that I may have worked in. This is only for education. Thank you.